Hello and welcome to this R tutorial. So in the previous tutorials we did the exciting step. We created our two regressors, the linear regressor and the polynomial regressor, and we visualized their results. So if we look at our graphs here, well, if we take the first one that we plotted, that is the linear regression graph, we obtain this straight line here that, besides its name, indicates that it's a linear model. And we saw that this model doesn't fit to the data very well because, as you can see, most of the prediction points are far from the real observation points. And then we were more satisfied when we visualized the polynomial regression results. First with the third degree, so that's the polynomial regression model with a 3 degree. And it's actually much better. We can see that the model is fitting much better to the data set, since obviously the predictions are getting much closer to the real values than the previous predictions with the linear regression model. So that was much better. And then we did even better by adding a new degree to our polynomial regression model, and we actually obtained this model that we have here. And now we can clearly see that this model is fitting very well the data set, because all the predictions are very, very close to the real values, and for some of them it's actually the same. So that's definitely an excellent model for us because we are trying to make the most accurate prediction as possible. We are trying to predict the previous salary of a potential future employee that is about to be hired, and this predicted salary is at the heart of the negotiation because this employee is telling that its previous salary was 160K and is asking for more than that. And therefore, we are trying to predict if this 160K salary is the truth or a bluff. Okay, so now that we get this curve and now that we see that we have an excellent model for our problem, we are going to validate this model, and this is the model we're going to choose to make our final accurate prediction. And that is what we are going to do in this tutorial. So let's do it. I'm actually going to this new code section that I prepared for you. So a first one to predict the salary associated to a 6.5 level according to a linear regression model. And then the second code section will predict the salary of the 6.5 level according to our polynomial regression. This one right here with a 4th degree. Okay, so let's start with the linear regression prediction. So we're going to do exactly the same as in simple linear regression. We're going to use the predict function, but actually something that's going to be different and will interest many of you. This time we're not going to make some predictions on a whole test set, that is on a vector of observations. We're going to make a single prediction. That is, we're going to make a prediction of a single level, which is going to be the 6.5 level. So you're going to see that the syntax is going to change. The technique to make this prediction is going to change, but it's actually as easy. So let's do it. We're going to call this prediction ypred as before. So be careful, ypred was before a vector, and now it's only going to be a single prediction value. So let's still call it ypred anyway. And same as before, we're going to take the predict function. So let's here take predict. Here we go. And now in this predict function, remember we need to specify first the regressor we want to make the predictions with. So that's the first argument. And then the second argument is the new data of which we want to make the predictions. Okay, so let's input the first argument. The first argument is our regressor. And since we're predicting the result with the linear regression regressor, and since we call this regressor linreg, then the first argument we need to input here is linreg. All right, so that's our regressor. And now we need to input the new data of which we want to make the prediction. So this new data is, as you understood, a single element, a single observation point. And this observation point is actually the 6.5 level here. So what we'll do now is to actually, since this 6.5 level doesn't exist in our data set, we actually need to create a new data frame containing this 6.5 value. We're not going to add this 6.5 level in our data set. We're going to create a new data set of only one line and only one column, that is of only one cell actually, and this cell will contain the 6.5 level. So let's do this. The syntax in R to do that is very simple. We just need to type here data frame separated by a dot. So frame, here we go, data frame, and now as you can see it automatically added some parentheses, and in these parentheses we need to input level equals 6.5. And that's it. That's actually all you need to do to make a single prediction using the predict function with a specific regressor that is here, the linear regressor. Let's check it out. Let's select this line and execute. Okay, ypred correctly generated. So as you can see, ypred is in the values here. We can already see the predicted value of the 6.5 level salary, and it's actually $330,000. So much higher than what this employee mentioned its salary was. So that's actually a good start for us. But remember, we don't want to keep the linear regression model. We want to keep the most accurate regression model. That is, of course, the polynomial regression model. So what we're going to do now is make the same prediction, but this time according to our polynomial regression model. So let's do this. Let's be efficient and copy this line because we will only need to change a few things, but you're going to see that this time it's not going to be that simple as here. It's going to be simple, but not that simple. We just need to add several arguments. And why is that? The reason is very logic. It's because since our polynomial regression model learned the correlations on this data set containing the level column and also the level 2, level 3, and level 4 columns, well, when we create this new data frame containing only the 6.5 level observation, well, since our polynomial regressor is based upon these 4 columns here, level, level 2, level 3, and level 4, then that means that in this new observation cell that we created for our level 6.5, we not only need to input the level, but also the level 2, the level 3, and the level 4. And that's what's going to change here. That's the only thing that is a little less simple than what we did before, but that's still very simple because as you can see, it will be very quick and easy to add these values. So let's do this. Let's not forget to change, of course, the regressor here. It's not linreg anymore, it's polyreg, because polyreg is the name we gave to our polynomial regression regressor in this formula right here. Okay, and so now, as I just explained, we just need to add here the polynomial features of our levels. So that means that we need to add level 2 right here. And don't worry, we don't need to compute it ourselves. We just need to add here 6.5 squared. And that will do it because, you know, level 2 contains the square values of the values in the level column. And that's why here we add level 2 equals 6.5 squared. And same for the other levels. We actually made a 4th degree polynomial regression model. So we need to add here 4 levels. And so I'm adding here level 3 equals 6.5 at the power of 3. And our last level, level 4, equals 6.5 at the power of 4. And that's it. It was only this little less simple thing to do, but now it's ready. So let's check it out, and actually we're about to find out the final verdict of the heart of the negotiation, which is the most accurate predicted salary that this future potential employee had in its previous company. So let's find out. I'm going to select all this and press Command and Control plus Enter to execute. Here we go. So what is the final value? It's $158,000. So very close to what the employee said. He said 160K and we predicted 158K. So that's awesome news because not only we can proceed to the right direction of our negotiation, but also we can now be relieved that this new future potential employee is very honest. And that's one of the best qualities to have in life, including professional life. So verdict, is it truth or bluff? Well, the final verdict is truth. So we're ending this tutorial as well as this section about polynomial regression on a good note. So happy ending, not only the verdict is truth, but also you can be proud of having built your very first nonlinear regression model. So congratulations again. And you're going to see that in the next sections we will be introduced to some new nonlinear regression models, and some of them are fascinating. So you'll see. I look forward to seeing you in the next section. I'll just add a final tutorial here, but that's not to build any more models. It's just that we're going to make a regression template, to build a lot more efficiently the next regression models. You'll have, of course, the code template, and you'll see how it will be very useful. So I look forward to seeing you in the next section. Congratulations again, and until then,